Hi, everyone. Thanks for joining this webinar. My name is Leif Reinert, and I'm a senior product manager on our EC2 accelerated computing team. Today, I'm excited to be joined by my peer, Amr Regab, a senior solutions architect, also on our EC2 accelerated computing team, to talk to you today about new Amazon EC2 DL1 instances powered by Habana Gaudi accelerators for deep learning model training workloads. So jumping right in, we wanted to start with why we decided to launch this new instance type and what we're hearing from customers in this space. So across really the industry today, we see this explosion in complexity of the models that customers are training as businesses seek to provide more natural experiences for their customers and deliver higher precision in their model predictions. Customers are training larger and larger models and retraining those models more frequently. So while 5 years ago we saw customers frequently training models with 100 million or 200 million parameters, we're now often talking to customers training models with over 100 billion parameters. And with this really comes increasing costs. So customers are looking for more complex, the latest possible compute solutions out there, and they're building larger and larger clusters of ML training optimized systems in order to train these larger models. But this has really become a barrier for innovation and growth, and customers being able to deliver new products for their end customers at the speed that they want. And so after talking with customers, they've given us the feedback that they're really looking for a way to lower their training costs. And this is where we saw an opportunity to partner with the folks at Intel and at Habana Labs on launching new Amazon EC2 DL1 instances. And these new instances feature 8 Gaudi accelerators and are specifically built for cost-efficient training of deep learning models. Based on our testing, we've seen that these new instances can provide up to 40% better price performance or cost to train, however you like to think about it, as compared to our latest GPU instances. Now we know that while the cost efficiency of the computer customers are using is important, for many customers, they also tell us that their developer productivity is just as important, if not more important, to their business. And that's why DL1 instances and Habana's software stack is integrated with TensorFlow and PyTorch so that customers can continue using the same ML workflows that they use today. Additionally, for customers using container orchestration services like ECS or EKS, will provide support with DL1 instances for those as well. And similar to our other portfolio of other instances in our portfolio for machine learning and deep learning, will provide easy ways to get started with deep learning containers, deep learning AMIs, and then down the road, we'll also provide Amazon SageMaker support for customers that prefer that more managed experience. So to give a quick summary here of DL1 instances and our instance size and specs, we'll offer one instance size currently at DL1 24x large. This will have 8 Gaudi accelerators, 96 vCPUs, 768 gigabytes of system memory, 400 gigabits per second of networking throughput. For pricing, we'll offer DL1 instances at $13.11 for on demand. This pricing is actually 60% lower than our EC2 P4D instances. Then for reserved instances or instance savings plans, we'll offer our 1 year and 3 year offerings at $7.87 and $5.24 respectively. So to give you a sense of what's actually in the box for DL1, DL1 instances will have Intel Xeon Cascade Lake processors for the CPU. They'll have those 8 Habana Gaudi accelerators for deep learning model training, each with 32 gigabytes of high bandwidth memory per accelerator. For networking and storage, we'll provide 400 gigabits per second of networking and 4 terabytes of NVMe storage. So for networking, this is aligned with the highest networking that we provision for almost any EC2 instance. And this is so that when customers ramp up on DL1 and they move from training models on a single node of DL1 to multiple DL1 nodes, they can have that efficient internode communication. For communication within the box, the Gaudi accelerators are connected peer-to-peer at 100 gigabits per second in an all-to-all connectivity. So every Gaudi accelerator can communicate with every other Gaudi accelerator in the box at 100 gigabits per second. And we've actually seen really nice scaling efficiency with this, and we'll have some benchmarks to share later that illustrate that. As we mentioned also in the last slides, the Habana software stack, named the Synapse AI SDK, is integrated with TensorFlow and PyTorch. And for customers that really like to squeeze every bit of performance out of the chip itself, they'll also have the ability to develop custom kernels to meet their workload requirements and really optimize performance. For use cases, this should look pretty familiar for most of our infrastructure. For deep learning, we see use cases like object detection and segmentation, things like manufacturing defect detection, fraud detection, and inventory management. In the image classification and segmentation space, we'll also see autonomous vehicle perception models, security footage, and video identification. And in the NLP space, we'll see things like text generation, subject matter queries, and question and answer use cases. So while these are the use cases we expect customers to use for DL1 today, we also know that over time customers will look to add things like more like fraud detection and recommendation models, and really expand on these use cases as the Habana software stack matures. So moving on to some benchmarks. Now, this is a comparison of DL1 instances as compared to some of our current GPU instances that we see many of our customers use today. So looking at a vision model training workload, we looked at ResNet 50 training using a Lars optimizer with a mixed precision data type running through TensorFlow. You'll notice that we see Habana Gaudi accelerators, or DL1, performing at about 20 to 30% greater than in training throughput than what we might see on one of our P3 systems. As compared to our latest, one of our P4 systems, it's about 40 to 50% slower in training throughput. And so, this is an important point we wanted to make clear to customers, is that DL1 and Gaudi accelerators, they're not necessarily meant to be the most premium or highest performant overall training system in our portfolio, but where they're really meant to provide customers benefit is in that cost to train, overall cost to train, and cost efficiency. And we'll flip this a little bit later and show exactly what we mean there. So another thing I'll point out is when we look at one Gaudi accelerator scaling up to 8 Gaudi accelerators, you see a really nice scaling efficiency between Gaudi and quite comparable for V100 and A100 as well. And so that 100 gigabit per second interconnect, although it's not quite as highly provisioned as we might see in some of our GPU instances, we still see a nice scaling efficiency. To give you a sense of NLP as well, we looked at BERT large pre-training in phase 1, also in a mixed precision data type running through TensorFlow. And you see a similar story, 20 to 30% higher performance and training throughput than what something similar to our P3 system, and 50% or so lesser performance and training throughput than a similar system to our P4D. So this is hopefully a good guidance in where customers can expect Gaudi performance to fall relative to our other portfolio. Now, next we want to show where we really see Gaudi becoming a compelling option for customers. So we just showed raw training throughput. Now we want to dive into actually price performance, or how much is it costing you per image processed in your training workload. So when we take our training throughput that we see on DL1 and we look at this on a per image basis, or dollars per image, we can see for ResNet 50 models, using a Lars optimizer with a mixed precision throughput, we're able to save upwards of 40%. In this case, we saw 42% savings relative to P4D. And then looking at BERT large in a pre-training, also in phase 1 with mixed precision, we saw a savings of around 13% relative to P4D. Then when we go further, we can actually compare this to our P3 instances, and those savings become even more compelling, reaching upwards of 50 to 60%. So this is really the story that we wanted to share with customers is that you're able to get really solid performance from DL1, comparable to some of the most commonly used GPU platforms out there today, but we're able to offer that at a much more affordable price point. So moving on, we focus these benchmarks specifically on single node trainings. We showed up to 8 Gaudi accelerators, one full DL1 instance, and we know that as many customers, as we mentioned before, they're actually building larger clusters of systems, and multi-node or distributed training is important as well. So while today we likely won't see many customers using DL1 for distributed training, we designed this system such that over time this could be used to build really large, efficient distributed training systems. So we'll post our EC2 availability. We'll have distributed training via Elastic Fabric adapter. So we're providing that network interface with OS bypass when scaling out to multiple instances, combined with that 400 gigabits per second of networking, and then high-speed storage systems like Amazon FSx for Lustre. And when we combine this suite of distributed training features, what we get is a really nice scaling efficiency going from one node to many DL1 nodes, and we're able to communicate with high throughput between nodes and keep each of those nodes saturated with training data, and we get that really nice training performance in scaling out. So this, we imagine over time, as Habana software stack matures, as customers become more familiar with the Habana environment and begin scaling out to multiple nodes, they'll be able to take advantage of these nice distributed training features as well. Another thing that our customers really ask us about on Gaudi and with DL1 is how are we able to provide that lower price point? And a lot of that actually comes out of the Gaudi accelerator architecture itself. Habana has designed these accelerators to deliver higher efficiency and really achieve really high utilization of each unit of compute within the chip. So the chip itself contains a centralized gem engine for matrix multiplication and fully programmable tensor processor cores that are adaptable to meet the requirements of many deep learning workloads. For memory architecture, they provide 32 gigabytes of HBM2 memory. So this is pretty similar to what we might see on a GPU platform, and in some ways can make it easy to actually move a model that is running on a similar GPU over to the Gaudi accelerators and using the same batch sizes, same model size. And then for accelerator interconnect, as we mentioned before, every Gaudi is connected in an alt-to-alt interconnect with 7 by 100 gigabit Ethernet on every Gaudi in DL1. So what this means is that by using this standard interface of Ethernet as opposed to any proprietary switch or specialized switching mechanism, Habana is able to offer this chip at a lower price point, and we're able to pass those savings on to AWS customers as well. Giving another kind of deep dive into the Habana side of things and the software suite, we mentioned that many customers are interested in that framework integration layer using TensorFlow and PyTorch and operating at that framework level to train and build their deep learning models. But there's also these TPC programming tools. Customers can build their own kernels for execution on the Habana software stack. Habana provides a graph compiler and communication libraries such that customers can perform all reduce and efficiently administer the communication between each Gaudi accelerator. And so this entire software stack is actually integrated as well into our deep learning AMIs and deep learning containers so that customers can just get started right away. But this is a quick snapshot of each piece that the Habana team is providing with the Synapse AI SDK. Finally, we see that customers often ask us, well, okay, I've got my model, and now how easy is it to actually migrate it? Now, here we show a really, really simple example of an MNIST model. Changing just 3 lines of code, we're able to properly load the Habana modules into our environment as a TensorFlow plugin and target that accelerator for execution. Now, It will not always be this easy. I think depending on your model, depending on your environment, there may be additional changes you need to make. But we wanted to show this to illustrate that at the fundamental level for basic models and for getting started on DL1, it's really quite simple, and you're really able to continue using that same TensorFlow or PyTorch code that you're using today. So to give one more final overview here of the different tools that Habana provides as part of the Synapse AI SDK, Habana will have profiling tools that allow you to monitor the performance of your workload, identify bottlenecks, and make sure that you're addressing those and achieving full utilization of the Gaudi accelerator. They provide this kernel library and TPC programming tools for customers that are developing their own custom kernels and would like or just writing code to interface with the Gaudi accelerator itself. And then they provide the Habana communication libraries. These should look very similar to what customers are using today for collective communications across multiple GPUs. But in this case, you'll use the Habana communications library and be able to administer the communication across multiple HPUs or Habana accelerators. To help customers get started, Habana will have a developer platform. So this is at developer.habana.ai. Here they have docs that give details on the Gaudi architecture, how to get started with using Gaudi, some tutorials on quick ways to take a model and migrate it. They also provide a model references library that has quick recipes for a number of models that Habana is already optimized for fully. So things like ResNet 50 and BERT, Mascar CNN, SSD, customers can get started quickly running these models on the Gaudi accelerators. And then so that customers see all of the models that are available to them and what's actually coming as well, they provide on GitHub transparently their roadmap. So customers will be able to see what's under consideration, what's in progress, what they've completed already, and be able to upvote or contribute to the models coming into the Synapse AI SDK and in that pipeline, so that the Habana team can take your feedback and make sure that they're focusing their development efforts on the models that are most important to our AWS customers. So now I'll pass it on to Amr to provide a quick demo of the DL1 instances and how you might be able to get started quickly running them and view their capabilities. So I'll pass it over to you, Amr.
Okay, thanks so much, Leif, for that exciting overview of DL1. So now I'm going to show you an instance deep dive of the DL1 instance. Here we are logged in to a DL1 24x large. The first thing that you'll want to do is for all the AMIs that we're going to be supporting for DL1, as Leif mentioned, for both EKS, ECS, the DL AMI, as well as the marketplace AMIs provided by Habana, those will come with the drivers already installed. And so at launch, you can immediately see the status of the 8 Gaudi accelerators by typing in HL-SMI. And this will show you all 8 Gaudi accelerators, the temperature, wattage, and amount of memory that is available. The next thing that you'll want to do is also take a look at the individual network links. And as Leif mentioned, there are 7 by 100 for each Gaudi accelerator. To view that, you can actually run a utility that has a script that will actually query for those network links. And if you run that, you'll see that for each Gaudi accelerator, we have 7 ports up. And so you want to make sure that these 7 ports are up and available, running to instantiate and get ready for distributed training across the 8 Gaudi accelerators. Also, you'll be able to actually see the individual address space for each of these links. If you take a look at ifconfig, each one will be numbered. So if you wanted to, you can look at ftool 56, and you can see here that each link is a 100 gig network, and for each link, so there's 7 of them, so 7 by 100 for each Gaudi accelerator. Now what we'll actually take a look at is running a workload. Now I'll actually do this through a containerized environment, which is actually very similar to the quick start guide in the Habana GitHub repo. So first what we'll do is we will use Docker and we'll pass in our Habana runtime, passing in all Habana devices into our environment. There's also the Docker image provided by Habana that you can use. In this case, we're going to be looking at TensorFlow 2.5 from their vault, and we're also going to pass some additional parameters. We also have, in this case, we're going to be running the ResNet 50 benchmark that Leif just showed in his slide deck. We have that in our data directory on the host. So once we execute that, we're now going to be in a shell within our Docker container. We will go ahead and git clone our model references and then cd into the directory for the ResNet Keras scripts. And those scripts are the ones that will be available on GitHub as well. Next, we will export the Python path for some custom modules, as well as defining the network links between all of the Gaudi accelerators. And this, again, all of this will be provided in the AMI that you select either from the marketplace, the DL AMI, or the instructions on building your own AMI as well. And then finally, we can actually instantiate the ResNet Keras script. Here we'll be using bfloat 16. We'll run for 40 epochs. For the purpose of this demo, we'll just run for a couple of epochs just to see the performance. And we're going to be using the Lars optimizer with Horovod, calling all 8 Gaudi accelerators with a batch size of 256. And again, our data for the ImageNet data is actually located in /data ImageNet. And so once this starts up, you'll immediately see the links between the Gaudi cards are available, and then it will start to initiate the training. This will take a few moments to start up. So what we can do is we can fast forward to when we'll actually see the training actually start. Now that we have fast forward a bit in our training, we can see that our performance of all 8 Gaudis is 12,970 or so images per second. So that is a quick overview of the Habana Gaudi DL1 instances. Thank you so much.
Okay, great. Thanks, Amr, for that overview. So now that we've shown you how you can quickly get started on DL1, we've talked about the reason we decided to launch DL1 instances, provided an overview of the specs of DL1 and the cost savings that customers might see using DL1. We want to jump into some customer testimonials and share with you some stories about customers that have completed a POC on Gaudi or seen the potential for DL1 instances to transform their business. So starting with Seagate. Seagate, as many of you may know, is a leading global provider of storage solutions. And they were able to complete a POC on Gaudi accelerators for manufacturing defect detection and ensuring that the storage solutions that they provide to their end customers are always top quality and free of defects before they hit the hands of their customers. And where we wanted to highlight with this quote specifically is that they saw potential that as Habana enables broader coverage of operators, there's potential for expanding to additional enterprise use cases. And this is really something we want to highlight with all customers is that, today there's a set of models that Habana supports, but over time, this is going to continue to grow into additional use cases, additional model types, and we'll be able to expand the potential use cases that customers can use DL1 instances for and gain that price performance benefit. Another company is Fractal AI. Fractal AI uses deep learning to aid decision making across numerous industries, from CPG to retail to manufacturing. And they specifically highlighted that their computer vision use cases and using DL1, they saw a lot of potential in making their end technology more cost competitive and accessible to a broader array of customers. So while on previous infrastructure, it may have been more difficult to provide that lower price point, DL1 instances can unlock cost savings for our end customers that allow them to make their end products more accessible overall. Moving on to a couple more. So Leidos is a leading provider of technology services for multiple clients in the healthcare space. And where they saw an opportunity with DL1 is using DL1 to unlock insights from really massive data sets and frequent retraining of their models. And that's all for the mission of solving some of the world's most urgent medical challenges, which is super important to all of us right now. And Leidos was able to begin some early testing with Gaudi and see great potential in DL1 to help them meet their business goals there. And then finally, we wanted to highlight RiskFuel. RiskFuel is a technology company in the financial services industry that uses deep learning throughout their business to provide portfolio managers and insurance providers real-time valuations and risk sensitivities. And so, as you can imagine, their business is really founded on having really accurate accurate deep learning models that can provide the most up-to-date data to those end customers. And so they're frequently training and retraining models, and the price performance improvement and cost savings they were able to see with DL1 or with Gaudi was a really compelling proposition for them. So that wraps up a few customer testimonials. Of course, we'd love to hear from any of you as well. If you have started running your workloads on DL1, training models on DL1, we'd love to hear more about your experience and be able to talk with you more about how we can continue helping you meet your business goals there. So to give a final overview of DL1 instances. These instances are available today in our US East Northern Virginia and US West Oregon regions. They're available through EC2, and you can launch these through the console or command line. They're also available to launch through ECS or EKS. And then down the road, we'll also have this support in Amazon SageMaker as well. So you'll be able to launch these through Amazon SageMaker and use that managed service with DL1. For purchase options, DL1 instances be available to purchase through on-demand, through reserved instances or spot purchasing options. You'll also have the ability to use DL1 as part of a savings plan. So for more information, you can visit our product detail page linked here. And to give you one final overview, DL1 instances are available currently in one size at DL1 24x large. We'll have 8 Gaudi accelerators, 96 vCPUs, 768 gigabytes of system memory, and 400 gigabits per second of networking. For on-demand pricing, we'll have these DL1 instances at $13.11 per hour. And then for 1-year RI and 3-year RI or ISP, we'll have these at $7.87 and $5.24 respectively. So thanks so much for joining this webinar, and we hope to hear from you soon about how DL1 instances are helping you lower your training costs. So thanks everyone, we'll see you soon.